Hello researcher, lovable welcome to material research review. Today we are going to see the semiconductor material application part 1. The title is trapping related breakdown on the elementary conduction in the carbon doped gallium nitride, and this article published in Advanced in Physics of Semiconductor, the physical status solidity part B. Recently only this article published in the Professor D. Foncon, the Institute of Solid State Electronics, TU Wayne, the Australia. For the highlight of this article, like the carbon defect can reduce the energy barrier at the semiconductor interface. The electron injected from n-doped gallium nitride to conduction band carbon doped gallium nitride, or the electron hole pair, the recombination process, the time the reducing the energy barrier. Previous report also several reporters there, like the external defect are not responsible for the current climate region. Only the external defect responsible for the pinning. This is the point only they resolve for this article. The gallium nitride means like a direct band gap semiconductor material. Mostly they use the light emitting diodes. The band gap of gallium nitride is the 3.4 electron volt. The special property, like optoelectronics devices, they will use this one for suitable for the solar cell array, the satellite. So mostly the high energy material they use for that satellite device. The author how they designing the device, initially they took like a nitrogen dope gallium nitride and transition layer silica substrate and the carbon doped gallium nitride. The thickness of carbon doped gallium nitride is two types thickness they quoted for the comparison purpose. One is the 200 nanometer and another one is the 300 nanometer thickness. And the nitrogen doped gallium nitride they took the thickness of that one for 1.7 micrometer thickness they took. After that the device they checked the electroluminescence experiment. Here that transparent layer, semi-transparent layer on the surface of gallium nitride, carbon doped gallium nitride, few nanometer thickness of titanium and gold conduct with diameter around 220 micrometer they used for the electroluminescent experiment purpose. And some non-transparent also, the surrounding they coated with titanium and aluminum, the content with 100 micrometer side length for the pure electrical measurement for the coated with non-transparent. Once the device is ready, they jump into the experiment. They checked initially the device recorded by the shipping for positive voltage up and down position. The both the the fixed voltage, like V controlled the V sweep and down sweep, both they compare. Both the different is the resistant 10 ohms they observed for the difference, the up sweep and down sweep. And after that they different voltage control observe different content the diameter d is equal to 100 micrometer and 300 600 they did compare then 300 600 the 100 micrometer diameter is showing good efficiency and after that the both the carbon doped with gallium nitrate both different diameter thickness they measured the 200 already I told 200 and 300 they both compare the 200 distance showing like the positive volt less and 300 nanometer thickness is showing the higher voltage like around 18 volt current it is showing. After that the electroluminescence measurement top side they using a charge coupled device image sensor and they took the 20x microscope objective. That image only here they showed you can see that image the fixed voltage they fixed 5 volt and current different current the 0.5 microampere the and temperature is 470 kelvin 475 kelvin the with integration time 600 second. You can see that black part is the conduct permitted the thickness of that transparent part 220 nanometer and the outside thickness you can see 100 nanometer. After that different voltage and different current they measured. Initially the the electroluminescent image the room temperature with T initial 1 second in onset difference biases. Initially the current is 2 micrometer and the voltage is 9 volt. Here only the spot seeing after they increase the current and voltage both the several micrometer current increase and voltage also increase microampere current. You can see here the 2 micro ampere current to 40 microampere it will showing the very bright current filament. Here the author mentioned for this one like due to that carbon defect only it will showing the that the current flow filament. And the electroluminescent measurement recorded the high voltage like 14 volt average current they observed 10 microampere. That image you can see the multiple current filament the splitting and after that the different time they did like here they fixed 10 volt and average current 3 microampere and 6 selection time they insert 0 to 31 second like you can see the 2 second it will the splitting and after 3 second they fixed the current filament. Here they observed splitting moving and merging but not observed in the, in the pinning type. After that like current versus voltage bistability regime. Here they observed like a generation of recombination introduced the non-equilibration transistor. Here you can see the image like voltage up and down the initial they got like a zigzag shape or S shapes. Another plot they compare with the single filament and multi filament. Here the real homogeneous state and stable filament branched in the and the small hump is like a simple device, and they mention for here in that plot. And average current density versus voltage, the voltage up and down, they compare. Here the multiple placement also, like same number of 1 to 4, they compared up to the multiple current placement in the steady gallium, carbon doped gallium nitride and nitrogen doped gallium nitride structure are formed. Both are spontaneously formed. The overall for this article, only one point they explain, like defect material can reduce the thermal energy barrier, but here they cannot mention, like they prepared a carbon doped gallium nitride. Here that carbon defect, they said that one no clear evidence for that one, because the thickness also gallium nitride, carbon doped gallium nitride, they said 200 to 300 nanometer. So that one they cannot prove for this article. uh, but the application that electroluminescence, they proved very good point, but that defect only not clear evidence, but the result is showing very good. And for this paper, to future possibility work, here that key point is the defective material can help to the reduce the energy barrier to the current flame from the splitting and moving, they said. So maybe the another defect material, previous video also we discussed the graphene defect can help to the formation deleting the dendritic for lithium metal batteries. So that also, like carbon graphene defect material also need to coat, will see the electroluminescence, how much efficient will come. So that also one of the good possibility for in future. And some other, here the key point is defect, it can reduce the energy barrier, this is the key point. So another any defect material also need to try, means good for in future. And thank you for your kind attention to watching this video. Welcome to your valuable comment. Thank you.